What's up everyone, Patrick here, welcome back. Moving on to another question. So we have to find the expression for the area of this shape over here. So we have x, which represents the length of this side over here, and then we have x plus 4, which represents the length of this side over here. Now notice that we can actually split this shape up into two separate shapes. So we could split it up into a rectangle, right? This is a rectangle because this has a different length than this. And then notice over here, we're dealing with a semicircle. And so for the total area, what we can say, it's going to be the area of the rectangle plus the area of the semicircle. Right, that's going to be the total area. Now, the area of a rectangle, we know it's what? Length times width. And then what is the area of a circle? The area of a circle is pi r squared. So the area of a semicircle is just going to be pi r squared divided by 2. So we'll have pi r squared over 2. Another way to write this actually is just 1/2 of pi r squared. And actually I'm going to write it like this instead because the r that we're going to plug in, it's actually going to be in fraction form. You could keep it the other way as well, but you're going to see in a sec when we do the algebra, it's better to keep it like this. And so now all we have to do is plug everything in, and everything should be in terms of x, because notice that that's the only variable that we're given in the diagram. So when we're given the expression, we can't just have length, width, we can't have an r here because those variables are not within here. So we have to plug everything in for length, width, and the radius in terms of x. Well, the area of the rectangle, that's pretty easy. It's just going to be x times x plus 4. Right, length times width, or if you want to call this the length and then this the width, it doesn't matter. Usually the width is smaller than the length, but again, they're just interchangeable. So I'll keep it like this. What's going to be a little bit more tricky is what do we have to plug in for the radius? What's the radius of this semicircle going to be? Well, notice the radius, it's actually just going to be half of this whole length. We know the whole length is x, so half of it is going to be x over 2, right? X over 2. X over 2 plus x over 2 would give us a full x. So the radius of this semicircle is actually x over 2. So we'd have 1/2 pi, and then we'll have, for the radius, we'll be plugging in x over 2, and then that's going to be squared like that. And so really from here, we just have to simplify this. We can also expand this. So if we expand it, we'll have x squared plus 4x. Now over here, let me work with the exponent first. When we have a fraction to an exponent, we could take the numerator to that exponent, take the denominator to that exponent, so we'd have x squared over 4. So continuing this, we'll have plus 1 over 2 times pi, and then this whole exponent would be x squared over 4. Like that, right? The numerator to the power 2, the denominator to the power 2, and then notice that we can multiply these two fractions. So we'd have 1 times x squared, so we'd have x squared plus 4x. And then over here we'll have 1 times x squared, which is just x squared, 2 times 4, which is 8. And then we could put the pi over here like that, right? Or we can also do, maybe to make it look nicer, we could say x squared plus 4x, and then we can maybe put the pi with the x squared. So we could say pi x squared over 8, for example. Yeah, that's probably the nicest format. You may see with a question like this different formats for the solution in the back of a textbook, but I feel like this here would be the nicest. Right? So if you get something like this, just split it up into whatever shapes you need to, break down the areas, and then just make sure that your final expression is all in terms of the variables that are given in the diagram.